Okay, problem number 14. Let f of x and g of x be piecewise defined functions on the interval x is in between -4 and +4. And then we're defining a new function, h of x, to equal f of x divided by g of x. So this is weird. We're getting some new function that we're not looking at. So like I can't look at this and know exactly what h of x is going to look like, but I can figure out a lot of things about it. So question A says, at what x value does h of x have a removable discontinuity, and how do you know? Well, what is a removable discontinuity? A removable discontinuity is a hole. You get a hole when you have a common factor in the numerator and denominator of a fraction of a rational function. And h of x is defined as a rational function where f of x, the top function there, is my numerator, and g of x is the denominator. So where would this thing have a hole? Well, it's going to have a hole at x equals 3. I know that because both functions, f of x and g of x, have a y value of 0 there, which means since h of x is defined as f of x divided by g of x, it's quite literally division, we're taking the y values of f and dividing them by the y values of g. Well, at the x value of 3, both graphs have a y value of 0. So h of x would equal 0 over 0 at the x value of 3. And hopefully we know that 0 over 0 means we have indeterminate form, which means we have a hole. And a hole is just a simplified way, a layman's term for a removable discontinuity. Well, then question B says, at what x values does h of x have a non-removable discontinuity, and how do you know? Well, a hole happens when a rational function is defined as 0 over 0. A non-removable discontinuity, aka a vertical asymptote, happens when you get 0 only on the bottom of a fraction. So not in the numerator as well, but only on the bottom. That's when we get vertical asymptotes, 0 on the bottom. So what is the bottom of our function? The bottom of our function is g of x, the Brown function, and that has two spots where it's equal to 0, there and there. So both of those will give h of x vertical asymptotes, non-removable discontinuities. So x equals -3 and x equals 0. And we're going to need to use that idea to help us with C, because C is a limit question. What the hey? Does the limit as x approaches 0 of h of x exist, and how do you know? Well, as x approaches 0, we're talking about this section right here, right? So let's figure out what's happening to the left of 0 and to the right of 0. Well, we already determined that we have a vertical asymptote at 0. So all we need to know is, does the limit exist at that vertical asymptote? And remember, there are two different main types of vertical asymptotes. There's a vertical asymptote like a 1 over x graph, where on either side of the asymptote, your tails go to opposite infinities. And then there is a vertical asymptote like a 1 over x squared graph, where on opposite sides of the asymptote, both tails go to the same infinity. This limit would exist, this limit would not exist. For a limit to exist, the graph has to approach the same y value from both sides of the limiting x value. So will that happen here? No, it won't, because g of x crosses the x-axis there. So if you're thinking about g of x as a factor, since it crosses the x-axis there, that factor would have to have an odd multiplicity. And when a factor has an odd multiplicity, if that factor is in the numerator, it means it's an x-intercept that crosses. But if that factor is in the denominator and it's an odd multiplicity, it means it's a vertical asymptote that's going to behave in this manner, where the tails will be going to opposite infinities. Another way you could think about that is to think about what we have. We know it's undefined at 0, but what happens to the right of 0? Well, to the right of 0, g of x is negative, and f of x is positive, so h of x is negative there. On the left of it, g of x is positive, f of x is positive, so h of x is positive. And so we know we have to be approaching infinity as we get closer and closer to an asymptote. And from that little reasoning right there, I know that my graph has to be going to negative infinity as x approaches 0 from the right, and positive infinity as x approaches 0 from the left. So no, this limit does not exist. Final question, D, what is h of 4? Well, we're quite literally defining this function h of x as f of x divided by g of x. So h of 4 will equal f of 4 divided by g of 4. F of 4 is negative 1, g of 4 is positive 1, so h of 4 is negative 1.